Alex with us. We have Mr. Alex CT, is the firefighting instructor, Marine Engineering Training Institute, Cochin Shipyard Limited. To talk a little bit about him, he has a distinguished 42-year career. Mr. CT Alex has served 18 years in the Indian Navy and 21 years in the Aircraft Rescue and Firefighting Department at Kochi International Airport. So we have second individual from CIAL. Post-retirement, he instructs firefighting at the Marine Engineering Training Institute, METI, and serves as visiting faculty for ARFF at CIASL Academy. So today he's going to be talking about aviation fire safety, embracing new technology and fuel. So I'd request Mr. Alex to please come on stage. Can we have a big round of applause for Mr. Alex?
Good afternoon, esteemed aviation fire safety experts, professionals, and colleagues from India and across the globe. It is an honor to share this stage with each one of you, whose expertise and dedication have saved countless lives and inspired countless others. In the realm of aircraft rescue and firefighting, every day presents unique challenges and opportunities. Today, our focus is on the future, on the transformative power of new technologies and the evolving landscape of aviation fuels. As we convene here, let's not just embrace technologies and fuels of tomorrow, but let us also embrace the camaraderie and shared purpose that unite us as ARF experts. So welcome to my presentation, Aviation Fire Safety, Embracing New Technologies and Fuels. Together we will illuminate the path forward for our dynamic and ever-evolving field. In the first part of our presentation, we will explore cutting-edge advancements that are empowering us to respond to emergencies with greater precision, efficiency, and safety. Our discussion will encompass a spectrum of innovations, including electric ARF vehicles, drones for real-time situational awareness and firefighting, as well as the utilization of fluorine-free foam, compressed air foam, and encapsulator agents. These technologies are not just enhancing, but fundamentally transforming our operational capabilities. In the second part, we will shift our focus to the dynamic landscape of aviation fuels and its profound implications on our operations. We will examine how the emergence of sustainable aviation fuels, hydrogen-powered aircraft, and electric and solar-powered aircraft are going to reshape the very nature of the incidents we face and the strategies we employ. Also, we will address the challenges accompanying these innovative fuels, including the unique fire dynamics of hydrogen and sustainable aviation fuels, the limited exposure to emergencies related to these new fuels, the delicate balance between safety and eco-friendly fuel adoption, the risk associated with the lithium-ion batteries in electric aircraft, and the complexities of detecting and managing hydrogen leaks in hydrogen-powered aircraft. Together, we will examine potential pathways forward in navigating these challenges. Aircraft rescue and firefighting stands as aviation's final defense, tasked with responding to emergencies involving aircraft at airports. Our core mission is to save lives and to minimize property damage in critical situations. As the world of aviation evolves continually, so too must our approach to aircraft rescue and firefighting. One of the exciting facets of this evolution is the integration of cutting-edge technologies into ARF operations. Let us explore the latest advancements. Electric ARF vehicles. Electric ARF vehicles represent a significant departure from the traditional diesel-powered counterparts. One exemplary model is the Stryker Volterra, known for its outstanding features. The Stryker Volterra is a hybrid electric ARF vehicle. It maximizes driving and pumping performances by seamlessly harnessing electric and mechanical powers. This vehicle offers an electric mode for fire station entry and exit with zero emissions, contributing to a safer and healthier work environment. Furthermore, Panther Electric from Rosenborg is also making waves in the electric ARF vehicle realm. Yesterday, Mr. Robert Pollinger, Senior Vice President of Rosenborg International AG, delivered an insightful presentation on the Panther Electric. Therefore, I will just briefly touch upon its key features. Panther Electric is emerging as a fully electric ARF vehicle. It is in the final stages of transitioning from concept to series development. It is a game-changing innovation. The company website claims it will be made available by the end of this year. Panther Electric blends the safety and functionality of the current generation Panthers with the advantages of electric mobility, leading ARF into the age of e-mobility. Let us now discuss drones and how they can enhance our operations. Drones equipped with thermal cameras and other sensors provide valuable situational awareness from the air, helping firefighters in identifying the extent of a fire or locating stranded passengers in an accident site. The main benefit of drones is increasing the speed of information and providing accessibility in hard-to-reach areas. These tools allow us to see the complete picture of a scene. In a Federal Aviation Administration article, it was mentioned that the airport rescue and firefighting personnel participate in live-action exercises using drones. Drones are revolutionizing emergency response. Drones are being actively explored as a means to deliver firefighting agents directly to aircraft fires, representing an innovative application in emergency response scenarios. Let us now delve into an innovation that is at the heart of our commitment to safety and environmental responsibility. Fluorine-free foam, or F3 as it is referred in FAA advisory circulars and documents. F3 is a pivotal step in addressing our environmental concerns. It provides a safer alternative by shifting away from fluorinated foams. Let us explore the key advantages of F3. F3 is non-toxic and environmentally friendly. Unlike traditional fluorinated foams, F3 contains no para- and polyfluoroalkyl substances, or in short PFAS, which are known to be harmful to the environment and health. Moreover, F3 is highly effective in controlling and extinguishing fires thanks to its rapid foam blanket formation. Lastly, and perhaps most importantly, F3 is biodegradable, which significantly reduces its long-term environmental impact. Transitioning to F3 successfully requires equipping our personnel with the knowledge of its application. We need to work closely with the regulatory authorities to ensure the safe adoption of fluorine-free forms. This includes compliance with global efforts to reduce PFAS contamination, aligning our practices with responsible environmental standards. Embracing F3 is about fulfilling our pledge to environmental responsibility. By embracing innovations like this, we enhance safety while preserving the environment we protect. Now let's move on to another promising technology in the realm of firefighting agents, compressed air foam, or CAF. Compressed air foam utilizes compressed air or nitrogen to generate a unique foam with micro-sized bubbles. Compared to traditional foams, CAF offers superior fire suppression. The dense foam blanket effectively smothers fire and inhibits reignition. The microscopic bubbles absorb heat rapidly, accelerating cooldown and minimizing damage. CAF requires less water compared to traditional foam, conserving our water resources. CAF has a promising future in aviation fire safety. Research is ongoing to optimize CAF for widespread adoption in ARF operations. Encapsulator agents. Mr. Rane, Kiran Rane, previous speakers spoke about this and the mechanism of extinguishing fire in detail. So I'll briefly touch upon the key points. Encapsulator agents are revolutionizing firefighting. Encapsulator agents are special water additives that form structures called spherical micelles. When mixed with water, they alter the droplet structure, reducing surface tension and creating smaller droplets that make heat absorption faster. These agents have proven effective in extinguishing A, B, and D class fires while also successfully containing lithium-ion battery fires. Encapsulator agents have been recognized in the latest FAA advisory circular, underscoring their importance in fire safety. All these groundbreaking innovations we have discussed so far exemplify the aviation industry's unwavering commitment to elevating safety standards, mitigating environmental footprints, and optimizing operational efficiency. Now that we have discussed some of the exciting technological advancements in ARF, let us now turn our attention to the evolving landscape of aviation fuels. Environmental concerns have compelled the aviation industry to establish ambitious targets aimed at achieving net zero carbon emissions. The international aviation industry made a resolute declaration to achieve net zero carbon emissions by 2050. This commitment isn't just a pledge. It is backed by accelerated efficiency measures, energy transition, and innovative initiatives across the aviation sector. Collaboration with governments worldwide is a crucial part of this mission. The International Civil Aviation Organization has welcomed this ambitious target. It has set its own long-term aspiration goal of achieving net zero carbon emissions for international aviation by 2050. This vision entails profound reductions in aviation CO2 emissions moving towards near zero levels. The Federal Aviation Administration has also set its sights on net zero carbon emissions by 2050. Their approach includes the development of cutting-edge aircraft technologies and an increased reliance on sustainable aviation fuels. As we navigate this path towards net zero carbon emissions, we encounter exciting innovations in aviation fuels. Let us explore these advancements, examining their potential, impact, and challenges. Sustainable aviation fuel. Derived from sources as diverse as used cooking oil, municipal waste, and seaweeds, SAF offers the potential to slash emissions by up to 100%. It is a crucial player in achieving our net zero carbon emissions goal. A Virgin Atlantic Boeing 787 Dreamliner called Flight 100 has become the first transatlantic commercial flight to be powered using 100% sustainable aviation fuel. The passenger flight completed its maiden journey from London and landed in New York. The aircraft is said to have run on 70 tons of fuel made mostly from waste cooking oil and animal fat. Emirates has become the first airline to operate an Airbus 380 demonstration flight powered by 100% sustainable aviation fuel in one of its 4 engines. Let us now come to electric propulsion. Clean and quiet electric power is transforming electric propulsion. While challenges like battery capacity exist, electric propulsion is making headway, particularly in smaller aircraft and shorter routes. A hybrid approach combining battery and aviation fuel propulsion is extending flight ranges. This approach offers promise for a greener aviation future. Hydrogen, whether utilized as a jet engine propellant or in fuel cell generators, presents promising opportunities in aviation. However, its widespread adoption faces technical hurdles which aircraft manufacturers are actively working to overcome through their innovation and research. Airbus aims to introduce the first commercial aircraft powered by hydrogen to the market by 2035. Cochin International Airport stands as the world's pioneer in solar-powered airports. Now the company aims to establish the world's first hydrogen plant within an airport. This strategic initiative anticipates the growing need for hydrogen fueling infrastructure to support the emerging era of hydrogen-powered aircraft. Use of solar power in commercial aviation is still in its early stages. Solar-powered planes harness the sun's energy to power motors and onboard batteries. While these innovations in aviation fuels hold promise for a more sustainable aviation future, they also present unique challenges for our personnel. Imagine a commercial aircraft powered by SAF experiencing an engine fire during takeoff. This scenario presents some unique challenges for our personnel. First of all, the combustion behavior of SAF might differ significantly from traditional jet fuels. This requires ARF teams to undergo specialized training to understand SAF fire dynamics and apply appropriate suppression techniques. ARF personnel might have limited experience with handling SAF-related incidents. Ongoing research and development will be crucial to create advanced firefighting equipment and protocols specifically tailored to SAF incidents. Collaborative efforts between the aviation industry, ARF organizations, and regulatory bodies are essential to establish clear regulations and procedures that ensure safe and sustainable operations while maximizing the environmental benefits of SAF. Let us take the case of a hydrogen-powered aircraft. Imagine an experimental hydrogen-powered aircraft experiencing a fuel leak on the tarmac. This incident creates a potentially dangerous situation requiring swift action from our personnel. Our teams must quickly assess the situation, identify the leak source, and take decisive measures to mitigate the risk of fire or explosion. Let's explore the key challenges. Challenge 1. As Mr. True said, hydrogen is invisible, odorless, tasteless, making leak detection extremely difficult. Specialized sensors and equipment are essential to pinpoint the leak source accurately and prevent further escalation. Challenge 2. Hydrogen burns rapidly and at high temperatures, posing a significant threat to responders and nearby structures. Challenge 3. Hydrogen leaks can lead to rapid pressure buildup in enclosed spaces, increasing the risk of explosions. Controlled venting and ventilation procedures are crucial to ensure the safety of everyone in the vicinity and prevent catastrophic events. Challenge 4. Coordinating with specialists familiar with hydrogen technology is essential for a safe and effective response. Our personnel may need assistance from these experts to understand the unique properties and hazards of hydrogen and navigate the situation effectively. Let us now imagine an electric aircraft parked at the gates, undergoing its routine charging process. Suddenly, a malfunction occurs within the battery system, sparking a fire. This incident throws our personnel into action, demanding swift and well-coordinated response to mitigate the danger and ensure the safety of everyone involved. What are the key challenges? Unlike conventional fires, lithium-ion batteries are susceptible to a phenomenon known as thermal runaway, where the heat generated by the fire causes a chain reaction that rapidly intensifies the situation. Our personnel must first de-energize and isolate the electrical systems on board before attempting to extinguish the fire. The potential for reignition remains due to the residual heat trapped within the battery modules. To effectively address these challenges, our personnel must undergo specialized training for lithium-ion battery challenges. They must learn safe procedures for de-energizing electric aircraft. They must also use specific firefighting techniques, adopt proper ventilation and post-fire monitoring procedures. Effective communication and coordination strategies are crucial for emergency response. By investing in this training and equipping our teams with the necessary knowledge and resources, we can significantly enhance their ability to respond effectively to battery-related fires in electric aircraft. In summary, our presentation delved into the cutting-edge developments that enhance aircraft rescue and firefighting capabilities. We have discussed electric arc vehicles, the utilization of drones, showcasing their potential to elevate our operational efficiency. Furthermore, we explored the significance of fluorine-free foams and their eco-friendly attributes, compressed air foam, and encapsulator agents. We have also discussed the emergence of new aviation fuels, such as sustainable aviation fuel, electric aircraft, and hydrogen-powered aircraft, underscoring the challenges accompanying their integration. As we conclude, let us distill the key takeaways from our discussion today. Above all else, our operations are dedicated to safety. Adherence to rigorous training, regulatory compliance, and continuous improvement is the foundation of this dedication. The aviation industry is rapidly advancing with electric and hydrogen-powered aircraft, sustainable aviation fuels, advanced vehicle technologies leading the way. Our personnel are at the forefront of adapting to these innovations, ensuring safety remains paramount. Effective emergency response relies on seamless coordination and collaboration among our teams, local authorities, and international partners. Cross-border cooperation and information sharing enhance our ability to respond to global challenges. In an era of environmental consciousness, our operations are aligning with sustainability goals. Efforts to minimize environmental impact during incidents and the responsible handling of hazardous materials are integral to our mission. Engaging with our local communities and fostering understanding about our role is essential. Embracing change. Change is inevitable, and our operations are embracing it with open arms. We commit to continuous learning, adaptation, and staying ahead of emerging trends to safeguard the future of aviation. As we conclude, let us remember that our personnel are the unsung heroes. We stand ready to protect lives, property, and the environment during aviation emergencies. Our dedication, expertise, and unwavering commitment to safety make aviation safer for everyone. Thank you for your attention. Let us continue our journey toward excellence in aircraft rescue and firefighting. Before we wrap up, I would like to take a moment to express my sincere gratitude to Mr. Ajit Kumar, our esteemed Chief Conference Organizer, whose mentorship and guidance gave me this opportunity to speak to this distinguished gathering. I am deeply grateful to Mr. Cletus M. John Packiam, Executive Member of the Organizing Committee, for his meticulous review of my paper and invaluable feedback that significantly improved my presentation. I also wish to express my heartfelt thanks to Dr. Subhash Kumar, Mr. Selvaraj Arumugam, and Mr. Hari Kumar for their steadfast support. Once again,